So imagine you're at this like surplus sale, right? And you buy this old, heavy industrial steel filing cabinet.
Oh, I love those things. They weigh a ton.
Right, exactly. So you get it home, you pull open that top drawer, and you're probably expecting to find, I don't know, some rusty paper clips, maybe some forgotten tax forms from the 90s.
Yeah, just typical office junk.
But instead, you discover this meticulously cross-referenced card catalog. And it's not just tracking one specific thing, it's mapping out literally everything. I mean, from highly obscure functional programming paradigms all the way to like the exact pH levels required to breed freshwater fish.
Wow. I mean, that kind of discovery, it really makes you realize you aren't just looking at a simple collection of data anymore. You are looking at, well, an entirely unique way of processing the world.
It's wild, and that is actually the perfect way to describe the experience we are bringing to you in today's deep dive.
It really is.
We've got this blog post, and it's dated April 16th, 2026. It's from a site called keymmmning.org. The author goes by the name Ang, and he refers to himself as an old software plumber.
Which is such a great title, by the way.
It is, yeah. And on the surface, the specific post we're looking at today is just a brief note about a debugging trick in a programming language called Haskell.
Just a tiny snippet of code, really. But if we treat that single post as a starting point, it unlocks so much more. We're going to explore the mechanics of a really clever problem-solving technique, the underlying philosophical differences in how programming languages structure thought, and ultimately we're going to decode the mindset of a staggeringly prolific tinkerer.
Okay, let's unpack this by starting right in the weeds of the technical frustration that actually prompted Ang's post to begin with.
Let's do it.
So if you've spent any time working on text parsers or, I mean, really any system that digests large chunks of data, you know that keeping track of your output is basically half the battle.
Oh, absolutely. It's a nightmare if you lose track.
Right. So this post is titled Notes on Haskell Programming, Part 110, Simplify Tokens Debugging. And Ang is, he's parsing content, which naturally involves breaking that content down into these manageable little pieces called tokens.
Right.
And to verify that his parser is actually behaving, he wants to print every single token to his terminal side by side with the content it represents.
Which, that is standard practice.
Yeah.
You absolutely need visual confirmation of your state when you're doing this kind of work.
Yeah.
But the problem arises when the data you are feeding the parser isn't just like a simple string of text, it's full paragraphs. When you push all of that to a terminal, the text wraps, the formatting breaks, and the visual hierarchy you need to actually read the debug output.
It's just completely destroyed. Yeah, it's like trying to read the spines of books on a shelf to find what you need, but instead of just the title, someone has taped the entire first chapter to the outside of the spine.
Oh, that's a perfect analogy.
You just can't scan the shelf anymore. The structure is totally obscured because there's just too much raw text getting in the way.
Exactly. And that visual clutter, it translates directly to cognitive fatigue for a developer. Debugging requires holding this very complex mental map of your software's state in your head.
Right, which is exhausting enough.
It is. And when your console output is just this unreadable wall of text, you end up burning mental energy just trying to parse the output itself, rather than solving the actual logic bug.
Yeah.
So Ang recognizes this friction, right?
Yeah.
And he decides to build a dedicated helper function called summarise to handle it.
And it's a really elegant fix because rather than letting the paragraph just bleed all over the screen, the summarize function acts as this like ruthless editor.
Yeah,
It evaluates the string, and if it's too long, it only prints the first 10 characters, inserts a comma or a little break, and then prints the last 10 characters. Everything in the middle is just stripped out entirely.
And what's fascinating here is this specific mechanical choice to preserve those terminal boundaries.
What do you mean?
Well, a lazier approach, right, would be to just grab the first 20 characters and chop off the rest, truncate it. But by keeping the head and the tail of the string, Ang solves a very specific parsing anxiety.
Oh, because you need to see where it ends.
Exactly. If you only see the first 20 characters, you have no idea if your parser accidentally swallowed the punctuation mark at the very end of the paragraph. By seeing the exact start and the exact finish, you confirm the integrity of the token's boundaries while drastically reducing all that visual noise.
That makes so much sense. It provides the absolute maximum amount of structural confidence with, the absolute minimum amount of pixel real estate.
Exactly.
But Ang doesn't just drop the snippet and move on. He details the implementation. And he explicitly flags this conceptual hurdle for his readers. He notes that to build this conditional check, deciding whether to print the whole string or to summarize it, he uses something called guards, which in Haskell, they're denoted by the pipe symbol.
Right, the little vertical line.
Yeah. And then he immediately warns anyone coming from an Elixir background not to conflate Haskell guards with Elixir guards.
And this is where we shift from a simple debugging trick into, honestly, the philosophy of language design. Because Ang writes extensively about both Haskell and Elixir. He knows firsthand that while both languages use the term guard, they apply them to fundamentally different mental models of programming.
See, my initial thought reading that warning was that it might just be a syntax clash. You know, like the kind of friction you feel when moving between languages where one uses curly braces and the other relies on indentation.
Right, like Python versus C or something.
Exactly, just muscle memory at the keyboard. But the way he frames it, it seems way deeper than just a syntax thing.
Oh, it is entirely structural. So in Haskell, a guard is a highly flexible tool for evaluating Boolean conditions within the body of a function. It evaluates whether a statement is true or false, and then it branches the logic accordingly.
Okay, so it's doing the checking inside.
Yes. When Ang wants to check if his text length is less than or equal to 20, he uses a guard. It operates a lot like a standard if-else ladder that you'd find in almost any imperative language.
So the Haskell guard evaluates the data after it's already inside the function's domain.
Precisely.
But if I'm remembering Elixir's paradigm correctly, Elixir relies really heavily on pattern matching.
Right.
Instead of evaluating a true or false condition after the data is inside, pattern matching looks at the shape of the data entering the function.
Yeah.
It's like checking if a physical key matches the shape of a lock before you even bother trying to turn it.
That is an excellent way to conceptualize it, and that brings us to how Elixir actually uses guards. In Elixir, guards are an extension of that pattern matching philosophy. They sit in the function header itself. They act like a bouncer at the door of a club.
I love that. A bouncer.
Yeah. The bouncer doesn't just check if you have an ID. They check if you meet a specific set of criteria before you are even allowed to step onto the floor. If the data doesn't satisfy the guard at the function signature, that specific clause of the function simply will not execute.
It just rejects it entirely.
Exactly. And the program just drops down to look for another function signature that does match.
Wait, so if I'm an Elixir developer reading Ang's Haskell code and my guards are stuck at the function header acting as bouncers, how would I replicate this internal Boolean logic? I mean, if I can't use guards to evaluate conditions inside the function body, what's the native Elixir approach?
See, Ang anticipates that exact friction. He clarifies that an Elixir developer wouldn't force a guard to do this job at all. Instead, they would reach for a completely different construct called cond, C-O-N-D, short for condition.
Okay, con.
Right. And cond is designed specifically to take in multiple expressions, evaluate them sequentially, and then execute the block of code associated with the first one that evaluates to true.
You know, if you're a developer listening to this, you've likely experienced that mental whiplash. You jump into a new language, you try to translate your logic word for word, and the compiler just fights you every step of the way.
It's so frustrating.
It really is. And Ang is highlighting that you can't just translate syntax, you have to translate your entire approach to problem solving. Haskell encourages you to branch logic flexibly inside the expression, but Elixir encourages you to define rigid, pattern-matched entry points up front to build fault tolerance.
It forces you to respect the grain of the tool you're using. And the fact that Ang pauses a highly specific tutorial on parser debugging to meticulously clarify this cross-language paradigm shift, I think it tells us something vital about how he processes information.
Here's where it gets really interesting, because Ang's meticulousness in setting strict 10-character boundaries for his debugging output and, his insistence on defining the philosophical boundaries between Haskell and Elixir, it isn't just some isolated coding habit.
Not at all.
That exact same obsession with categorizing, containing, and documenting data spills over into the margins of his entire website. To understand the code, we really have to look at the environment it lives in.
We do. And the archive sidebar on knm.org is honestly a marvel of sustained effort. The sheer volume of output, it just defies typical blogging habits.
It's staggering. Let's just look at the numbers for a second. This specific post we're talking about is Notes on Haskell Programming, Part 110, 110 sequential logs just on this one language alone.
And he's been at this for a long time.
Yeah, he has been maintaining the site since 2011. In the year 2024, he published 732 posts. In 2025, he published another 730 posts.
That is basically 2 posts a day.
Without fail for 2 entire years. And looking at April 2026, by the 16th of the month, the date of our source post, he had already published 48 posts.
If we connect this to the bigger picture, the quantity is impressive, sure, but the breadth is what truly reveals his mindset. The categories list is basically a cross-disciplinary map. He isn't narrowly focused on just back-end server architecture.
Oh, not even close. Alongside the extensive multi-part series on Python, Rust, Go, and artificial intelligence, the archives veer into entirely different domains. Like right next to Notes on Haskell Programming, Part 106, you'll find Notes on Gardening, Part 868.
Part 868?
Part 868. You'll also find logs on his daily body weight in a dieting series that's well past Part 111. And you'll find deep dives into aquatic biology, like his notes on tackling diatoms and managing water pH for his epistogramma.
It's amazing. He is applying the exact same rigorous step-by-step documentation process to propagating a blue daze plant or balancing the biological load of a fish tank as he is to writing type-safe functional code.
It's all the same to him.
Exactly. To Ang, a nutrient imbalance in a hydroponic setup is fundamentally the same as a token parsing error in Haskell. They are both system states that need to be observed, debugged, and documented.
It really makes you wonder about the motivation, though, doesn't it? I mean, most people who log their gym progress or their garden yield, they just keep it in a private notebook on their phone.
Right.
It's one thing to document your code for a professional portfolio, but why go through the effort of publicizing the daily minutia of your hobbies with this level of academic rigor?
Well, the About section of his site actually gives us the ideological framework for this. Ang describes himself as tinkering late into the night with free, Libre, and open source software, or flawless.
Okay, flawless.
Yeah, and he actively directs his readers to support organizations like the Electronic Frontier Foundation, the Free Software Foundation, the Tor Project, and Wikipedia.
Ah, and those organizations, they represent the absolute core of the open web. The belief that information should be unpaywalled, decentralized, and just accessible to anyone who wants to learn.
Precisely. For someone deeply steeped in that floss ethos, knowledge isn't property to be hoarded, it's a commons to be contributed to. So when he encounters a problem, whether it's understanding how Elixir handles pattern matching or figuring out why a specific fine-leaf aquatic plant is failing to thrive in his tank, he views the solution as public data. By putting his rough drafts, his minor confusions, and his tiny debugging victories out in the open, he treats the internet not as a stage for personal branding, but as a collaborative workbench.
It's the ultimate expression of working out loud. He's building a permanent, searchable record of his own learning curve.
Yes, exactly.
So if another late-night tinkerer in 2026 is struggling with a terminal completely overflowing with Haskell tokens, Ang's 10-character summarise function is already indexed and waiting out there to save them hours of frustration.
And, it reframes our entire understanding of that summarise function. Earlier, we noted that the function was designed to trim the noise so the underlying structure of the code could be seen.
Right.
In a way, Ang's entire blog does the exact same thing for his life. By diligently documenting his diet, his garden, and his code, he is actively trimming the noise of daily existence to reveal the structure of his own learning process. He treats his entire life as an open-source project to be continuously debugged and refined.
That is such a profound way to look at it. We've really covered some fascinating terrain today. I mean, we started with a seemingly microscopic issue, just a developer trying to keep a text string to exactly 10 characters on either side so it wouldn't break his console formatting.
It's just a tiny formatting fix.
Yeah. But that practical necessity led us into this deep debate over language design, contrasting Haskell's flexible internal guards with Elixir's rigid pattern-matched gateways.
Right.
And finally, we zoomed out to discover this decades-long, relentlessly maintained archive where software, biology, and daily habits are all treated to the exact same open-source rigor.
It really serves as a powerful reminder that the tools we use shape how we think, and how we choose to share our thoughts shakes the community around us.
So what does this all mean? Where does this leave you listening right now?
Well, Ang describes himself humbly. He's just a software plumber tinkering in the night. Yet, through nothing more than sheer, consistent effort, he has built an incredible reservoir of public knowledge. We spend so much of our digital lives consuming fleeting, algorithmically sorted content that just disappears the moment we scroll past it. So here's the provocation to take away from all this. What is a hobby, a skill, or even an ongoing frustration you possess right now that would fundamentally deepen if you forced yourself to document it step by step for the rest of the world to see?
I love that. What is your version of part 868? Because maybe if you start openly documenting that tiny, persistent drip under the sink, you'll end up mapping out an entire new world for someone else to explore. Thank you for joining us on this deep dive. Keep tinkering, keep documenting, and we will catch you next time.